Here I'm looking at an Axopar 45, air conditioning by Mabru. So this boat had no air conditioning from factory, so we got to configure it the way that we wanted to. You'll see vents in crucial placements. So on this particular boat, what we have is two 17,000s, inverter type units, so 17 VI units, SE17 VI, one unit under the port side bench, one unit under the starboard side bench. Starboard side's not bothered, so I'll just open that up so you guys can take a look. So that's the unit right there, 17,000 BTUs. And what we decided to do, instead of doing the 3-unit configuration that we were used to seeing, we decided 2 units, and each unit does one side of the boat. So the starboard side 17 handles these 2 vents in the back. It handles these 2 vents at the helm, and you can I'm sure hear there's plenty of air coming out of there, plenty of air coming out over here. We have another vent in the head and another vent in the forward. Now for the port side unit, we have a 4-inch feeding, so to get a little bit more air into the forward cabin. We have a 4-inch at the helm, so to push a little bit more air into this forward section of the vessel. And we have the 2 3s back over here. So very good air distribution throughout the boat. As an example here, I got onto the boat and it was 77 degrees. So I set the boat for 65. The boat is now at 65. Compressor's still running, pump is on. Evaporator temperature's down to 41. Condenser's running really happy to 84. Starboard side unit, we're also set for 65. This unit showing 66. Compressor's on, of course. 66, 32. So this compressor's running a little bit harder because it hasn't reached that temperature yet. Condenser's at 88. Once again, compressor's running at a higher capacity. It's running a bit faster because it hasn't quite reached that temperature. These are variable capacity systems, so the compressors will speed up and slow down based on demand. This is a generator powered boat, so it has a single Victron Multiplus 3000 from the factory. The way we configured this is that the starboard side unit is connected through the inverter so that when they're operating with the engines, they don't have to run the generators or run the starboard side unit. And the alternators will give enough output to allow that 17 to run, even at full capacity without depleting the battery bank it's connected to. The units draw about 1100 watts a piece, so 1100 watts at full speed. That'll equate, we're talking ballpark about 85, 90 amps. And each engine alternator is outputting 115 amps. So we certainly have enough. Over here in the back, we have our pump system. So we have our 2 intakes, 3/4 inch, 3/4 inch bronze Kuroko strainers, pump for port side unit, pump for starboard side unit. So typically on these installations, you're more used to seeing the plastic basket strainers, but here in the larger boat, we're obviously a bit lower in the water, and we have the space to put these larger through holes, and the customer requested the larger 3/4 inch. Typically, we would use the low profiles. If we look at the discharges, you can see we have a nice flow coming out of there. We actually have a larger through hole than needed. We used a 1-inch through hole that we made up some adapters to fit our 5/8 hose. That way the stream wouldn't shoot out. And that's the same on port as it is on starboard. And that flow that you're seeing out of a 1-inch through hole is in fact out of a tiny little pump that you see over there. So that's our 650 gallon per hour pump. We have the bleeding valves in case any airlocks occur. Here in this case, the boat was splashed. The boat hadn't been in the water before. All I did was open the 2 intake valves. I never actually got around to purging. I didn't need to purge it. The air came out on its own and I didn't need to use the purging valves, but in the event an airlock happens, those purge valves have been very helpful to our customers.